When it comes to understanding and applying nutrition, a concept that's really important to get your head around is calories and energy balance. We'll chat briefly about what this means in regards to energy balance and your goals, as well as how it informs macronutrients and why it's important to understand this. Calories are simply a measure of energy intake. Energy cannot be created or destroyed. It is just changed from one form to another. So when we are eating food or drinking calorie-containing drinks, our bodies convert the stored chemical energy into usable energy. Adenosine triphosphate, or ATP, is the energy we use for every single process in our bodies. I won't confuse you too much with it, but it is important to have a general understanding of what I mean by this. So over here, you can see that I've mentioned 1 calorie is 4.18 kilojoules. Kilojoules are also a measure of energy. It's just metric versus imperial. It's like saying 1 inch equals 2.54 centimeters. You're talking about the same length, you're just using different measurements. Likewise with 1 calorie or 4.18 kilojoules. That is the amount of energy required to heat 1 gram of water by 1 degree Celsius. That's how it's standardized. For the average adult, you need 2,000 calories a day or about 8,700 kilojoules. I find it easier to work in calories because it's much easier to break down a 2,000 calorie day into 20 units than it is to break down an 8,700 kilojoule day. You can use whichever measure you like, but your nutrition plan will be written in calories for you. This diagram may look confusing at first glance, especially if you haven't done university level biochemistry or biology. So I just want to preface this by saying I'm not trying to turn you into scientists or dietitians. I just want to demonstrate how energy is produced in different ways. When we eat food, our cells have to break it down into usable energy, which is ATP, like I've mentioned just before. If we are doing fast respiration, meaning fast energy turnover, this is for things like explosive exercise, weights, sprinting. Our body doesn't have that much time to produce energy. So it will use this first cycle here, glycolysis, to produce this ATP here. If we have more time, if we're doing slower exercise and our bodies can utilize oxygen, we use the Krebs cycle predominantly instead. Both of these cycles spit out ATP and also feed their byproducts, NADH, into this other cycle here, which produces more ATP. As a byproduct of that, we get rid of carbon dioxide and water. Like I said, you don't need to know the finer details of this, just know that different exercise uses different energy pathways. When we talk about calories, we speak about total daily energy expenditure, or TDEE. Don't let the acronyms confuse you. It basically just means how much energy you burn in one day. When you look at the overall calorie burn from one day, it's broken up into different sections, the largest portion of which is towards our metabolism or our cellular turnover. This is BMR, or basal metabolic rate for short. Basal means baseline. So if you're thinking about your baseline metabolism, when we say baseline metabolism, we basically mean how much energy you burn at complete rest. I also like to call this coma calories because it doesn't take into account activity, talking, thinking consciously and moving, or digestion. So that is your baseline metabolism. That is the bare minimum of calories you burn per day, keeping your body alive. Your body uses so much energy just processing oxygen and filtering your blood at each minute. 10% of our energy goes towards digestion. When we break food down in our bodies and turn that into a usable form, that takes up calories. We also burn calories with our activity. This is broken down into non-exercise and exercise. This is NEAT for short, or EAT for short, because it's exercise activity thermogenesis, which just means what you burn when you exercise. Exercise is the things that we think of as exercise. So it's a set session where we do cardio or weights or something repetitive for a reason. Non-exercise activity is the things you do just existing. So cleaning, cooking, walking around, fidgeting, The only way to periodize your non-exercise activity is through a step goal. So we do a step goal here as an artificial measure of activity, and then we have exercise sessions, which are literally penciled and programmed with intention. I've broken this down here into ranges so you can see just how much everything takes up. Like I mentioned before, our bodies use so much energy just staying alive and keeping our organs turning over. This can be up to 70% of your day. This will be 70% of your total calorie burn if you don't exercise, because you've burnt less calories in the day if you don't exercise. Digestion is always 10% of the calories you eat. So if you eat 2,000 calories, you'll burn 200 calories in digestion. If you were to eat 2,500 calories, you'd burn 250 calories in digestion. This can only slightly be tweaked by increasing our unprocessed foods, increasing protein intake, and increasing fiber. We use less energy with digestion if we have carbohydrate or fat foods, or if we have highly processed foods that aren't very hard for our bodies to break down. Activity is 15 to 30%. So again, there's a bit of a range here because it depends on whether you exercise or not. If you don't exercise in a day, you'll burn less calories. It's fairly simple. If you do exercise in the day, that can add about 200 to 500 calories generally at the most to our day's burn. I've just broken this down further into numbers for you in case anyone's wanting to know exactly what that looks like on paper if someone was to do a pretty hard exercise session with about 300 calories. In terms of calorie balance, this affects weight and fat storage. Because we don't destroy energy, we just burn it and use it for other forms. If we have too much, our bodies can store it. This is a really clever survival mechanism because back when we were cavemen, we'd have periods of starvation and periods of surplus food. So our bodies were able to metabolize and store a big storage of food for the times where we didn't have food available. However, now we always have food available, so it's not that helpful anymore. If there's too much energy, we put fat down. Fat is a really easy storage form because it's not stored with water, so it's not heavy, and we can store a large amount of calories per gram in a very efficient way. If we don't eat enough calories, we lose fat because our body simply takes energy from our fat stores. If the correct amount of energy is consumed for how much you burn each day, then your weight stores and fat stores will stay level. If your physique goal is fat loss, you'll be put into a calorie deficit with your nutrition plan. A calorie deficit simply means eating less than your total daily energy expenditure. If your TDEE is about 2,000 and we wanted to set your deficit at a 25% deficit, this would be 25% less than 2,000 calories. So you'd be eating 1,500 calories. For muscle gain, you need to eat more food because you're putting down more muscle tissue. So if your main goal is bulking or adding muscle mass, and you're not looking at body recomp or fat loss, you'll be eating a calorie surplus, which is more than your TDEE. So instead of eating around 2,000 calories, for example, you may be eating 2,200 calories regularly. This allows your body to recover really well from training and to create extra muscle stores. If your goal is to maintain your weight or do a bit of body recomposition, which is where you gain muscle and lose fat, you'll be eating in a calorie maintenance or a calorie balance. This allows you not to lose too much muscle mass or fat or to gain too much muscle mass or fat, and you can go through a slow recomp process. You can find your calorie breakdown on your flexible nutrition plan, but please ask me if you have any more questions about this.